right.
We'll get started here in a minute. Make sure you have your notes out, please. Make sure our notes are out and ready to go. Mrs. Schmidt here today? Okay. Today I am going to give you time where you can work on your assignment because I know we just had that yesterday. So I'll give you some time where, and I'll try to put an example up today just to make sure that you're comfortable, and I'll leave it on the board so you can use it as reference. Oh yeah, that's what I need to do, or this is what I want. So I'll give you two. I may pick up right out of the book, so I might get a freebie here today. We only have one topic today. One topic. It's very, very straightforward. Prime versus composite. It's one of those. Yeah, it's a super easy concept, and it actually just uses what you learned yesterday. So it's just, I think it was a perfect idea to like talk about this because it fits so well with what we've been learning, and it's not crazy difficult. So that's even better. So I mean, we can just kind of bridge off what we just learned yesterday. All right. So prime versus composite. It is a part of number theory, talking about like the concept of what numbers and how they fit together and how they work. But we're going to be dealing with this idea of factors today. So what you had in your homework yesterday is you had problems like this, right? And I think I even had the question from, I think it was Hannah, or was it Beth that asked me, what does the little f mean? They wanted you to factor that number apart, right? So they're giving you the number 20, and they'd like you to do that branching tree to figure out what are the different numbers that multiply to give you 20, right? So what you had to do, and you didn't have to make it look exactly like mine, but you had to have at least every factor that was possible for us. So what I always do is I always start with the number 1, I try 2, I try 3, I try 4, I try 5, 6, and I go for a few numbers, and I see what works. So like, what number do you take times 1 that would give you 20? Yeah, so that's easy, right? 1 and 20, right? Then we try 2. 2 times what gives me 20? 10, all right? So there's 2 and 10. So right now we're already at 4 different numbers that are factors, right? There's 4 numbers, 1, 20, 2, and 10. 3. 3 times 6 is 18, right? No, 3 times 7 is 21, so that doesn't work. So 3 doesn't work. 3 times 16 is huge. No. All right, what about 4? 4 times what gives me 20? 5. 4 times 6 is 24. 4 times 5 is 20. And we can stop there because these numbers are literally side by side. There can be no number in between them. So those right now are your factors. Okay? Does that make sense like what we did yesterday? That was your concept. Now here's the thing. By looking at what we did yesterday, I can tell you right now how this fits in with our concept today. This idea of composite versus prime. Let's first start with the word prime. In fact, I'm going to put these words over here so you can see them. All right. We're going to go through the definition of what prime is. Definition. All right. Prime number. It's a category of numbers, right? It's a way of thinking about numbers and how they fit together. Prime, by definition, is when you take a number and you break it into factors. So it's taking a digit contains only 2 unique factors. That's what a prime number is. Now, what that means, what this definition is, when you're looking at your digit, it only has 2 numbers for factors. 2 numbers. 2. Right now, how many factors do I have written on the board up here? How many of them? 6. Right, 6. There's 3 pairs, don't get me wrong, but there's 6 numbers. So, does this fit that definition? Is there only 2 unique factors? No. This number, what you're looking at, since there's a bunch of different factors here, there's a bunch of different numbers, this number is considered to be composite. So we're going to write that definition up there. digit contains more than 2. More than 2 unique factors. Okay, so like we just talked about in that number 20. We had 6 numbers on that board, right? 6 numbers, 6 factors. That means that number is automatically composite. It had more than 2. So typically, when you think of composite, there's a ton of composite numbers. I mean, if you think about even the homework you did yesterday, when I was betting on when you were trying out your homework, a lot of those numbers broke down really, really far, right? Like there was a couple of problems that had, maybe 6, 7 different numbers that you could have in there. Okay, can you think of any of those numbers you did yesterday, because if you started your homework yesterday, that there was only 2 numbers that it broke down into? Think back to that homework we did. So maybe you have that homework in front of you. So Cole's on the search. Is there any that when you're doing factors, it didn't go down very far?
49.
49. Ooh, well, let's talk about 49. So F of 49, right? So the factors of 49. Well, what's the first pair? Yeah, 49 and 1, right? But then there was one more, right? 2 didn't work, 3 didn't work, 4 didn't work, 5, but 7 did. 7 times 7. That's 49, right? How many different factors are there here? There's 3 individual numbers, unique numbers, right? There's 7 repeated, but there's 3 numbers there. This number that you have, and that was a good choice. This number you picked is still composite. It still had 3 factors to it. There's 3 individual unique numbers, right? Was there any other numbers on your list that didn't have more than 2? The number 15, or was it problem 15? Which one are you talking about? Is it the number 15 or problem?
I didn't finish it yet.
Oh, okay. So there should be at least one in there where it didn't go very far. Yeah, number 8. It was problem number 8, and this is the problem. It was the number 11. Okay, it was the number 11. Because think about this. How do you break down the number 11? What are the numbers that multiply to give you 11?
1.
1 and 11. Is there any other number? This right here is special when this happens. There's a lot of things. This right here, this pair, is a prime number. It only contains 2 numbers for factors, 2 unique numbers. It has 1 and the number itself. There was no other combination of numbers that can multiply to give you 11. So here, this number is prime. So this is a prime number. And these 2 are composites over here. These are composites. Okay, do we see the differences now? Like how prime numbers, there's only 2 factors, but everything else is composite. There's a ton of different factors here. Okay, so thinking about prime numbers, think about just small numbers that could be prime. Can anyone pick a number, like guess a number that only has 2 numbers for factors? Think of the number 5. That's a good one. Right, the number 5. The only way you can break down 5 is 1 and 5. That's a prime number. What's another one? Number 2. Right? Number 2 has a number, right? 2 and 1. Right? Is there any others? 3, 7, 11, 13, 17, 19, 23. There's an infinite number of prime numbers, but they're spread out. There's no rhyme or reason. There's no pattern to it. It's just they're just a list there. But what about the number 1? What about the number 1? What are numbers that multiply to 1? 1, right? It's 1 times 1, right? 1 times itself. Now, how many different numbers do you see there? Is there 2 numbers, or is there just 1 number repeating? There's only 1 unique number, right? The other number is the same. This number right here is not prime and it's not composite. It's not prime. It's not composite. It doesn't fit any of the definitions. It doesn't have more than 2, and it doesn't even have 2. The number 1 is unique. It's that weird in between. And we don't even consider 0. 0 works for anything. I personally would consider 0 composite number, because you can multiply 0 to anything. But the number 1 is special. It's not prime. A lot of people always get confused by that. It only has one unique number, so it doesn't fit any of the definitions. Okay. I wanted to show you this today, because I know, like, in some of your problems, you were kind of worried, like, some numbers broke down further, some didn't. And there's a reason. The numbers that went further, you know, there was multiple pairings, like you said. Those are composite numbers. And then some numbers don't. Okay, any questions with factors? Now, I know that some of you did factor trees like this. Some of you just made lists. So you just made a list, that's fine. I don't mind if you made the tree or the little document for this set. Just make sure you're finding every combination if there's more than one. That's the hard part about that homework. Okay, now what was the other topic we talked about yesterday? What was the second part of your homework? What was the second? We did factors, but what was the other? We did multiples, right? Multiples was a little bit different. Multiples, they gave you a number. Heck, I'm going to pick one of yours, just so you can see this. Let's see. Too many other homework open. Multiples. Number 15. So is that from number 3? Okay, so this idea of multiples, not factors, but multiples. So this is the second homework. This is the page 39 material. It was 1 through 5, 1 through 5. You have to do both A and B, right? But one of those problems looked like this. This is one of those examples. I think this is problem number 3 out of the book. Okay, what they wanted you to do is make a set of numbers that are the multiples of 15. So how I find this big list, and they want the first 10 numbers. The first 10. Here's how you do. You take 15 times 0. You always start with 0. What's 15 times 0? 0. Then you take 15 times 1. 15. And then you take 15 times 2. 30. Now, here's the best way you can do it. Some people go, gosh, I don't do that. I don't know how to take it times 3 or times 4. But all you're doing is you're just adding that number to itself. So how you get to the next group, how you get from here to the next one, you're going to know 15 times 3. Just add 15 to this number. It's just a list. So if I add 15 to this, I get 45. And then go on. 15 times 4 is 60. So I add 15 more. And that's how you do it. You have to go through the first 10 numbers. You have to list them all out. So if I keep going, when should I stop? What number should I get to? 150. I want you to end at 150. Now, I know that's technically the 11th number down the road, but that's what I want you to do. I want you to end at 150. How I know that? That's 15 times 10. So what do we have? 120, 135, 150. And that's where I want you to stop. That's 15 times 10. Remember, when you multiply by 10, you just put a 0 on the back. So that's how you know when you're going to end. Whatever your number is, put a 0 on the back. Okay, does that help you out with what you have to do? Okay, so there's 2 strategies here. You can multiply by, by 3, by 4, by 5, by 6, by 7, and finish at 10, or you just add your number over and over and over. So you get up to where your number has 0 back. Okay, homework today, page 39, page 38. Those are due which day? Thursday. Thursday is our last day in class this week, because I believe I will not see you Friday because of homecoming. So just make sure that you realize that. So that's when it's due. Okay? All right, you have the rest of the time right now, which is like 10 minutes. Kind of work. Maybe after lunch we'll introduce our next topic, but I'm going to give you some time today to work on this. Okay, make sure on that second page, the page 39, you're doing both A and B, 1 through 5, 1 through 5. A and B, which is top of the page and bottom of the page. Be careful. And on the first page, 38, make sure you're doing even, 2, 4, 6, 8. So on and so forth. All right, hey, let's go to lunch. Make sure if you're going through the lunch line, you're telling those people that are taking scores for homecoming dress-up days, hopefully you fit the parameters of what you have to dress up like. All right, so here's my question to you. How many people still need more time to kind of wrap up this homework? More time? Okay, I'll give you a couple more minutes here. We won't spend all the time working on homework. I'll give you maybe 15 minutes or so, and then we'll intro what we're going into tomorrow. Okay, does that make sense? Now, I think tomorrow might be our last day, because I think Thursday, Friday, we have a weird shortened schedule. So I don't know if I have you both days, or if I have you just one day on Thursday or Friday. So I'll look at the schedule here and I'll tell you. But I think last day is kind of our last full day of the week anyway, for us. Yeah, so I'll have you full tomorrow and Thursday. I just won't have you Friday. Friday will be the rest of the day, because they had to break it up since we're really out Thursday and Friday this week. And tomorrow, technically, but you guys are full tomorrow.
So we also have another prep.
Yep. Still a 2:25 dismissal. Do the coronation that day. In between announcements. Tug of war. Close building.
Bus is still running all the time though, right? Those days?
Yeah. Yeah. Another 10 minutes here, then we'll intro what our next topic is. If you're done with your homework, don't be afraid, you can always turn it in. Put your name on it. Yeah, so if you take some cool shots, then.
Okay, well, I have quite a few, so I'll just put them on your email address.
Good. Give it another 2 minutes here, and then we're gonna start our next topic. I think you guys are gonna like. You're gonna like this next stuff. All right, so I'd like you to take your notes. That's if you have your computers, put those away. If you have homework, put those away just for right now. And remember, homework's due this Thursday, so you have a couple days to go to work on it. You have tomorrow and it's due on Thursday this week. Remember, we have full class tomorrow, Thursday's full class, and then I won't see you guys on Friday this week. Just because of the way the classes work out, the alternator schedule on those days. All right, so sequences. This is the next topic we're going into. Now, the reason why, it's part of number theory, right? So the first thing I want to talk about is what is your definition of sequences, right? I want you to know that so you understand that there is two types of sequences. So here we go. Let me put this down for you. So this is the like the most generic way you can define a sequence. It is a list of numbers in a particular order. I mean, that's about as basic as you can get. Okay? So list numbers in a particular order. So what I mean by that is that I'm just gonna put a list up on the board, and I want to see if you guys can understand which order that I'm putting this in. All right, so take a look at this list. What can you tell me about it? Okay, yeah, just skipping numbers, right? So what numbers am I using? What are these numbers called? What's the category numbers? Okay. Let's see. 9 is not prime. 9 has 1 and 9 and also 3s. So it looks prime. The 9 threw you off. And that was an actually good guess. What other sequence am I putting that in? Odd. They're odd numbers. Yeah, they're odds. The only way you know the difference, because Alex, you were almost correct. The 9 threw us off. If the 9 wasn't there, I'd say prime. Okay, but we'd have to have the number 2 instead of the number 1, so that's another giveaway. Okay, these are odd numbers. So what's the next 3? What's your next 3 numbers going to be? 13? Keep going. 15, eh? Okay. What you just found is the next 3 terms, right? We call each number in the list a term. The next terms, so the next 3. So each individual term. We have what they call this number 1 up here in the beginning, and it's the first number in the list. That is called the initial term. Initial means starting, right? And then we have the second term, third term, fourth term, fifth term. Sequences are in a particular order. Most of the times you can look at the list and tell what the next couple terms are. Well, the thing that I love about these sequences, it's kind of like a little puzzle. You have to kind of notice the pattern. There is a pattern to it. And you have to find the next couple numbers, right? So, let me give you another list. Let's see if you can figure out the next 3 here. So here's another sequence. Okay.
Skipping by 4s.
Ooh, by 4s. All right, so let's check this pattern. So going from here to here. What was that? Going from 2 to 4. What's the space in between them? 2. Oh, so it's not by 4s anymore. This one was by 4s. Okay, so what you did, the pattern that Alex knows, that's what we call a common difference. That's actually a strategy. You actually named the strategy there. It is a common difference. You look at the space between numbers. It's actually a really, really interesting way to look at sequences. But now, here's the problem. What's the next 3 numbers? What's the next 3 going to be? Can we figure out what the pattern is? Because it's not jumping by 4s. What are we doing? How are we getting to each number? How do we start with
Well,
the 2?
like, since we're at 32, we're going to just go up 2.
So what do you think the next number is going to be?
34.
Ooh. Now, is that what's happening here? So you think 34 is the next number?
Yeah.
We went from 2 to 4 to 8 to 16. So you just think maybe it's the list of numbers in order like 2, 4, but I skipped 6 here. I went 8 and then 16. I don't think 34 is the next number.
64.
Oh, you're right. Okay. Next number is 64. Why? You're right, Sean. But why? How do you figure it out?
I just added 13, 32, did that together.
Yeah. That's one way to do it. You're adding the number to itself to get the next number. So to get from here to the next number, they added itself. You get from here to here, they added 4 plus 4. You get from here to here, added 8 to itself. Added 16 to itself. Add 32 to itself. Add 64 to itself. Add 128 to itself. You keep going. It's actually, all they did was multiply by 2, but you're absolutely right. You're just adding it to itself. Okay? You're doubling every single time. Now, what you're looking at here, this is a sequence. The numbers are in a particular order. There is a pattern that you can spot that would actually find the next couple numbers. That's why I like these. They're very open-ended, and there's different ways to think about it. If you thought about adding, I did multiplying in my head to figure it out. But not every sequence will be straightforward like this. Sometimes they take some serious thought to get from one to the next. So let me show you what I mean by this. This is a sequence. It's in a very particular order. The pattern is actually really kind of challenging to figure out unless you see it. The best strategy for this problem is do what Alex did earlier and look at the gap, that difference between your numbers, and you'll see the pattern in front of you. So what's the gap from going from 6 to 10? How did I go from 6 to 10? What did I do?
4.
I added 4, right? How did I go from 10 to 7?
Nicely.
How did I go from 7 to 9? Up 2. Went from 9 to 8. You see the pattern? Plus 4, minus 3. The next, what do you think it's going to be?
Plus 0.
Plus 0. Next number is 8. In fact, that's the correct way to do it. All I'm really doing is I skipped every other number. If you can see it, I skipped every number. It went 6, 7, 8. You'll skip the next number, which is this. Then it'll go 9. Then the next number, and every other number that I skipped is counting down. 10, 9, 8, 7. So then the next number will be 10. That's all I'm doing. I skipped every other number, and it was counting down versus counting up. But noticing that gap will actually help you. Okay? Tomorrow, we're going to continue on with this idea of sequences, patterns, see if you can figure it out.
Do we always come out?
Yes.
Okay.
I need to get the
Clipboard.
clipboard, so it's all marked up. Alright.
Wait, that was so bad. I'm pretty gonna get in trouble for that.
That was so horrible. Nice try though.
Like,
Austin was coming in.
Victoria, she wasn't working on it.
Austin.
He's like, so that's still posting. I think we just did that to be like funny. Like, nice try, new stuff. And he's
Look,
like,
I still think I have some on.
working.
So